In this complex number session 24, we are going to see about application of de Moivre's theorem. This part contains 3 parts. This video covers the first part. The first part we are going to learn about cos theta plus I sin theta whole power n and sin theta plus I cos theta the whole power n type problems and how to simplify these type of problems. And in part 2 we are going to see and discuss about 1 plus cos k theta plus I sin k theta the whole power n type problems and 1 plus cos k theta plus I sin k theta divided by 1 plus cos k theta minus I sin k theta the whole power n type problems. And in the part 3 we are going to discuss about the simplification of a plus ib the whole power n plus a minus ib the whole power n type problems. This is what we are going to see in application of de Moivre's theorem. In this video we are going to cover only part 1, that is cos theta plus I sin theta the whole power n and sin theta plus I cos theta the whole power n. You may see what is the difference between these two, because whenever we apply de Moivre's theorem it should be of this type, that is real part should be of cos theta and imaginary part should be in sin theta. But in this model, in this type, if you see here, the real part is not in cos, it is in sin, and the imaginary part should be in sin, but it is in cos. So here there is a difference. So now we are going to discuss about these two type problems. Before discussing this, first of all we must recollect our de Moivre's theorem and its corollaries. Now let's go to de Moivre's theorem. What do you mean by de Moivre's theorem? De Moivre's theorem states cos theta plus I sin theta the whole power n can be written as cos n theta plus I sin n theta. This theorem gives a very simple technique for us not to calculate the problem with power. It states if there is a power, just bring the power inside to the angle. That's all. It is very, very, very simple. Right. Now let us see the corollary. This is its first corollary. Here the small change is, here we have positive power, here we have negative power, and we have this formula. Is there any shortcut to follow this formula? Yes, very simple. Just multiply the sign of the power with this I symbol which is in the middle. So if we multiply these two, plus into plus, we'll get plus. So in our answer part we'll have plus in the middle, that is with I, that is plus I. Then just bring the positive value which is in the power inside the ratio along with the angle. So this cos theta will become cos n theta and this sin theta will become sin n theta. If you see this corollary first, if you follow this technique, we'll get that answer very easily. That is, we have to multiply the sign of I and the sign of power, that is plus into minus, we'll get minus. So we have to put minus in the middle along with I. After that, just we have to bring only the positive value of the power inside the bracket along with the angle. So this n will come here along with the angle and it will become cos n theta and this will become sin n theta. That's good. So let us see the next corollary. It states cos theta minus I sin theta the whole power n. Just do the same technique, that is positive sign is in the power and negative sign is in the middle. Just multiply these two. So plus into minus, minus. So we have to keep minus in the middle along with I, that is minus I. Then just bring this power n inside, that is only the positive value, that is cos n theta, and it will become sin n theta. And there is one more corollary, that is cos theta minus I sin theta the whole power minus n, that is equal to cos n theta plus I sin n theta. Will the shortcut work for this? Yes, surely it will work for this. Just multiply the symbol of the power with a middle symbol along with I. So minus into minus, it will become plus. You just keep plus in the middle. along with I. Then just bring only the positive value of the power into the cos ratio and into the sine ratio. When n comes here, it will become cos n theta, and when n comes here, it will become sine n theta. So we received it. So this is what a very simple shortcut to do any de Moivre's theorem problems. Moreover, we must remember one thing. To do any de Moivre's theorem, we must know how to move from this power n to this result. Moreover, from this result, we must know how to come back to the power. So this is what very important thing. If you see here, the right hand side, we have 4 formula result, but 2 are in the same category, that is cos n theta plus I sin n theta. Here also we have cos n theta plus I sin n theta. And another 2 follows next category, that is cos n theta minus I sin n theta. Another one is also cos n theta minus I sin n theta. So we have only 2 categories. One is with plus I, another one is with minus I. So let us see only these 2. So we must know how to come back again to the power. The easiest way is, if the middle symbol is plus, then bring plus n as power. See, here the value is n along with the angle. When we make this as a whole power, see the middle symbol, if it is plus, we have to bring plus as power along with this value, that is n. So it will become cos theta plus I sin theta the whole power n, like this. That's good. In case if it is in this type, that is in the middle, if you have minus I, again we have to take this n commonly outside like that. We have to take n as power, but we have to keep the sign as negative. So at that time we have to consider like this. We have to take minus and n. So if the middle, if you have positive sign, we have to take plus and this n. If you have negative in the middle, we have to take minus and this n outside as power. So if we do that, it will become cos theta and it will become sine theta. The middle negative symbol is taken out, so it will become plus. So the answer will be cos theta plus I sin theta the whole power minus n. So we have to remember this. If we want to go back to the whole power model, the work what we have to do is, if it is plus symbol, it is not a problem. Just you take this n as power and make it as power. If we have negative symbol here, you keep it in mind. When you make this as power, you have to take this minus also outside. So the power will become minus n and this minus will become plus, because minus is taken outside, right? So you know very well now how to move from this left hand side to right hand side and how to come back to the whole power model. So keeping these things in your mind, we have to proceed further, right? Now let us go to simplify a problem. Whenever you do de Moivre's theorem problems, there will be many brackets like this. For example, you just see a problem. This is a problem. Here if you see, this is one, this is another one, this is another one. 3 brackets are there. In each bracket we have angle and some power. Somewhere here we have plus I, but here we have minus I. So it is very hard for us to simplify this. So it is better for us to convert everything in terms of cos theta plus I sin theta. That is the best way. So try to convert this as cos theta plus I sin theta. Also try to convert this as cos theta plus I sin theta. In the same way, try to convert this as cos theta plus I sin theta. If we convert every brackets like cos theta plus I sin theta, what will happen? The next step will be like this. All the brackets are in this format, right? Simply it becomes like this, and it becomes cos theta plus I sin theta. This also becomes cos theta plus I sin theta. In case if you have some more bracket here, again you will have, it should be converted like cos theta plus I sin theta. Somehow everything is converted in this way. Now if you see all the brackets, all are with same base. If you think this is a, this is a power p, this is a power q, and this is a power r, and this is a power s, like that. So it is very simple for us to simplify this. So if we simplify, if all the terms with same base, it will have the same base. So our answer will be with a single base, that is cos theta plus I sin theta, and powers can be simplified. This is what the best way. So whenever we solve a De Moivre's theorem problem with so many brackets, it is the best way to keep all the terms in terms of cos theta plus I sin theta model. Right, now let us proceed with this problem. So we are going to convert every terms in the model of, in the type of cos theta plus I sin theta whole power n. Before diving into the problem, let us do some small problems. Before diving into big problems, let us see a small problem. Let us consider this cos theta, that is cos phi theta plus I sin phi theta whole power 2. How to simplify this? As I told you, it is our main goal to keep this bracket in the type of cos theta plus I sin theta. So we have to take this 5 outside. How to do this? As I told you, see the middle term. Is it plus? Yeah. Is it plus? Yes, it is plus. So just take this 5 and make it as power using this technique. This is what that formula, right? If it is in the formula, in the model cos n theta plus I sin n theta, we can convert this as cos theta plus I sin theta the whole power n. Just see the middle symbol, it is plus, so keep this as plus and take only this n and make that as power, right? So if we do this, right, here we have positive symbol, so we have taken plus symbol and this 5, and it became power now. So it is converted like this, cos theta plus I sin theta the whole power 5, and for this whole power 2, it is whole power 2. Now it is in the form a power m the whole power n. Formula is a power m into n. We have to multiply these two powers, so our answer will be cos theta plus I sin theta the whole power 10. So we have achieved it. If you want to simplify this, again make this power 10 to be inside the bracket. If you apply this, as I told you, just we have to multiply these two powers, plus into plus plus. So in the middle we'll have plus, and only we have to bring the number inside. So our answer will be cos 10 theta plus I sin 10 theta. So you must be very careful in this. You must know how to move from left to right, that is from power n to the angle, from this angle to power. You must be very careful, right? Let us see one more sum, that is cos 3 by 4 theta minus I sin 3 by 4 theta whole power 2. Again, it is our main goal to make this problem in this type. So how to do this? Very simple. As I told you, see the middle, what symbol you have? Minus. So we have to take this minus outside along with the power. So here, along with this number. Here the angle with the number with the angle is 3 by 4. With this number, you just bring this minus also outside and make that as power. This is a shortcut. So if we do so, it will be like this. That is, it becomes, we have taken this minus outside, so it becomes plus I. As I told you, we are trying to bring this 3 by 4 as power along with this minus. So our answer will be minus 3 by 4 that comes in the power. That's good. So we made this in this format, cos theta plus I sin theta the whole power minus 3 by 4. For this power 2, it is again power 2. As I told you, this is in the model a power m the whole power n. Formula is a power m into n. So let us multiply these two. When we multiply these two will get cancelled and the denominator will become 2. So the answer will be minus 3 by 2. So the result will be cos theta plus I sin theta the whole power minus 3 by 2. So again we achieved what we need. If you want to simplify this, if you want to make this power to be inside along with this angle, as I told you, just multiply these two, that is plus into minus minus. So in the middle we'll have minus I, and we have to bring only the positive value, that is 3 by 2 along with this angle. So it will become cos 3 by 2 theta minus I sin 3 by 2 theta, that is plus into minus minus. So in the middle it becomes minus I. After that we are just bringing this positive value 3 by 2 to the angle. So we have simplified it. So when the problem is like this model or like this model, whatever it may be, we have to convert them in the way that is cos theta plus I sin theta model, like this. We have to convert like this. We have to convert like this. So these two are the main work before doing a problem with de Moivers. Right. Now let's try to do the problem. This is the problem what we are going to solve. Our main aim is to make all the bracket in terms of cos theta plus I sin theta. So what to do? As I told you, if you see this first bracket, here 4 is here, but in the middle we have plus, so no problem, just we have to bring plus 4 as power. But if you see here, you have negative symbol here, that is minus. So while bringing this 2 outside as power, we have to bring the power as minus 2 and it will become plus I. If we see here, we have to bring the power as 3 and in the middle we have minus, so in the power we'll have minus 3 and this minus will become plus. So if we do this, this answer will be like this, right? See here again, here we have plus, so our power will be with positive and we have to make the 4 as power, so plus 4. If you see here minus, so we have to make the power as minus 2. So minus and 2 are taken outside as power, so it will become plus for this whole power 6 whole power 6. See here we have minus, so we have to bring 3 and minus as power, that is minus 3 as power. So this minus will become plus because minus is taken outside. And for this power minus 2, power minus 2. Now let us simplify this. It is in the form a power m the whole power n. So we have to multiply these two power a power m into n. So our result will follows like this. That is minus 2 into 6 is minus 12, minus into minus plus 3 into 2 is 6. As I told you, now all the brackets are the same base, that is cos theta plus I sin theta. That's very good. Now we can put all these things with the same base, that is cos theta plus I sin theta. Now let us try to simplify the powers. This is in the form a power m into a power n. Formula says that is a power m plus n. That means we have to write these two powers as it is. So cos theta plus I sin theta the whole power 4 minus 12. But here in the denominator we have 6. So if we bring this to the numerator, it will become minus 6. So it is minus 6. Now let us simplify this. Our answer will be cos theta plus I sin theta whole power minus 14. Right. Now the problem is simplified To get the final result, as I told you, we have to bring again this 14 inside to this angle. How to do this? Using the shortcut. As I told you, just multiply the middle term symbol, that is plus, and this power symbol minus. So plus into minus is minus. So in the middle we have to put minus along with this I. After that, just you have to put this 14 or bring this 14 alone, that is positive value 14 alone to this angle. So it will become cos 14 theta and it will become sin 14 theta, and this will become plus into minus minus. So the result will be cos 14 theta minus I sin 14 theta. This is what the simplification. I hope so you would have understood this. It is very, very, very simple. In this model, it is very simple because we have in the real part we have cos and in the imaginary part we have sin. So it's very simple. But in the forthcoming video, or sorry, in the forthcoming next or in the next problem, we are going to see sin with the real part and cos with the imaginary part, and we cannot apply De Moivre's theorem, because to apply De Moivre's theorem the real part should be cos and the imaginary part should be sin. But the next problem what we are going to see is with sin in the real and cos in the imaginary. How to do that problems? Let us consider the situation is like this. The given term is sin theta plus I cos theta. We cannot apply any De Moivre's theorem. If there is a whole power n, we cannot apply now, because to apply De Moivre's theorem the real part should be cos and the imaginary part should be sin. So let us do a small technique. Just we want I sin theta, and here we want I square. If we do so, this I square will become minus 1. So this cos theta will take the real part position and the sin theta will take the imaginary part position. So if we multiply this whole term by I, it will become I sin theta, it will become I square cos theta. So cos theta is coming under real part section and sin theta is I sin theta, so it comes under imaginary part section. So what we are going to do is just we are going to multiply this by I. To balance this, we have to divide it by I. So let us multiply this with I, that is I sin theta plus I square cos theta. So I sin theta plus I into I square cos theta. I square value is minus 1, so this is minus cos theta. This I came inside, so it became as 1. For the denominator I, it is there as it is. Now whenever we do a complex number problem, we never used to keep I in the denominator. So let us multiply the numerator and denominator by its conjugate, that is minus I by minus I. But here there is no need of doing like that. Simply let us multiply by I. Let us multiply the numerator as well as the denominator by I, so that the denominator will become a real number. So I sin theta minus cos theta 1 by I into I by I. Now let us multiply this. 1 into I is I into I is I square value is minus 1. So I by minus 1 is nothing but minus I. So we can write this as I by minus 1 is minus I into I sin theta minus cos theta. Now we can interchange the values. Before that, let us multiply everything by this minus. So it becomes minus I sin theta, minus into minus plus. So it becomes cos theta. I is kept outside. Only by minus, this negative sign, we are multiplying this two terms. So it becomes minus I sin theta, it becomes plus cos theta. Let us keep this cos theta in the front. Let the minus I sin theta be brought to the back side. So the answer will be I into cos theta minus I sin theta. So if you see this, whenever a problem comes like sin theta plus I cos theta, that is no need of worrying, that can be converted as I into cos theta minus I sin theta. Okay. In case instead of this plus I, if we have minus I, what will be the situation? Right. Let us consider that also. Let us consider there is a situation in that we have a term like sin theta minus I cos theta. So what we have to do, again we are in the same problem. In the real part we must have cos, but we have sin. In the imaginary part we must have sin, but we have cos. So if we multiply this by I, this will become I sin theta, so sin becomes imaginary. At the same time, when we multiply this by I into I is I square value is minus 1, so this imaginary moves out, it becomes real part. So as usual, we are going to multiply this by I and we are going to divide this by I. Right. Now let us multiply with this I. Our answer will be I sin theta minus into plus minus I into I square value is minus 1, that minus into this minus becomes plus cos theta. So now it becomes I sin theta plus cos theta into 1 by I. This I came inside this bracket. As I told you, we should not have I in the denominator, so let us multiply the numerator and denominator by I itself. So if we multiply like that, we'll get I sin theta plus cos theta, the same thing, this 1 by I into I by I. I into I is nothing but I square value is minus 1. So if we simplify this, our answer will be I sin theta plus cos theta into 1 into I into I square value, that is minus 1. If we simplify this, we'll get the answer as minus I. So that is minus I into this cos theta plus I sin theta. Now if you see here, we have cos with the real part and we have sin in the imaginary part. So if a problem comes like this, sin theta minus I cos theta, we cannot apply de Moivers theorem on this because real part should be cos and imaginary part should be sin. So this can be converted like this. Right. Now keeping that 4 formulae of de Moivers and these two techniques, we can simply solve these type of problems. Now let us consider in a summary. Whenever sin theta plus I cos theta comes, we should not keep this. We have to convert sin as cos and cos as sin. For that we have the formula, that is I into cos theta minus I sin theta, as we have derived. So if the problem is with plus I, then we'll have plus I here and the sign is changed here. Sin becomes cos and cos becomes sin. You can keep this in your mind. And in the second case, if the problem is like this sin theta minus I cos theta, then its solution is like this, that is this minus I comes here. If it is negative, it becomes positive. As usual, sin should become cos and cos should become sin. Like this, you can keep these things in your mind very easily. Moreover, you know all the de Moivers theorem, that is cos theta plus I sin theta the whole power n, and then cos theta plus I sin theta the whole power minus n, then cos theta minus I sin theta the whole power n, and cos theta minus I sin theta the whole power minus n. Right. So using all these formula, we are going to solve a problem. Let us see a problem. that is sine pi by 8 plus I cos pi by 18 the whole power 9. This is what our problem. Here we cannot apply De Morgan's theorem. You cannot make this 9 to get inside, because to apply De Morgan's theorem, the real part should be with cos and imaginary part should be with sine. So let us apply this formula. As I told you, if this is plus I, the answer will be starting with plus I into real part with cos and imaginary part with sine, and this will become there minus I. So I hope so. This is in this model, sine theta plus I cos theta. So plus I, then real will become cos and imaginary will become sine, and just change the sign. If it is plus, you just put minus. So this is what the formula. We are going to apply this formula. Here theta is equal to pi by 18. So if we apply this formula, our answer will be like this. That is I into cos of, instead of theta we have to write pi by 18 minus I into sine of pi by 18. For this, instead of this sine pi by 18 plus I into cos pi by 18, we can write this term as I into cos of pi by 18 minus I sine of pi by 18. For this whole power 9, we are having the whole power 9. This power is common to this I, also to this bracket. So it will become I to the power 9 cos pi by 18 minus I sine pi by 18 whole power 9. Now it is the exact way. We can apply De Morgan's theorem for this, because in the real part we have cos and in the imaginary part we have sine. So we can apply De Morgan's theorem very easily. Moreover, we can simplify this I power 9, because we have a formula that is I square is equal to minus 1. Using that formula, we can simplify this I power 9 also. So I power 9 can be written as I power 8 into I power 1. This I power 8 can be written as I square the whole power 4 into I. I square value is minus 1. So minus 1 the whole power 4 into I. Minus 1 the whole power 4 is nothing but plus 1. So 1 into I is equal to I. So we got the answer, that is I power 9 is nothing but I. So we can write this in this way. Moreover, this bracket is now ready for De Morgan's theorem also. So when we apply this, instead of I power 9, the answer received by us is I, that is replaced here. Here using De Morgan's theorem, as I told you, plus into minus, minus, just bring this 9 inside. So 9 comes inside and 9 comes inside. When we simplify this, 9 and 18, we'll get 2 in the denominator. So our answer will be I into cos pi by 2 minus I sine pi by 2. Cos 90 is 0 and sine 90 is 1. So our answer will be I into 0 minus I into 1. I into 1 is nothing but I. So I into minus I, our answer will be equal to minus I square. We know that I square value is minus 1. So minus into minus becomes plus 1. So this is what the answer. So we can do so many problems in this model using this concept. I think so you would have understood all these things. Keep all these things in your mind, and let us move to the next part in the next session. Thank you.